Hi guys, it's Mrs. Bracy, and we are going to be talking about Unit 3 on linear functions in this video. And this is the flashcard number 9 that you should have copied in class this week after your test. I'm just going to talk through it really quick. If you haven't had a chance to copy this, maybe you pause the video and take a minute to copy this so that you have it down. As you know, your flashcards get checked throughout the unit, so this needs to be done. So today we're going to be focusing on graphing linear functions. So our main focus will be on slope-intercept form. We call it slope-intercept form because f of x equals mx plus b gives us both the slope, which is the m, and the y-intercept, which is b. There's two other forms of a line, standard form and point slope form. We will be looking at those throughout the unit, so now you have them down for a reference. And as we talk about slope, we're going to talk about positive slope, which is moving up from left to right, negative slope, which moves down from left to right, zero slope, which is your horizontal line, and undefined slope, which is your vertical line. In order to calculate slope, which is also called the rate of change of the line, we use this formula here. M equals y2 minus y1 over x2 minus x1. And when you are given coordinates, the first x-coordinate is x1, and the first y-coordinate is y1. The second x-coordinate is x2, and the second y-coordinate is y2, and we would just substitute those values into this formula here to calculate slope. We will do that together in class. And finally, you do need to know what x and y intercepts are, and that's just where the graph crosses the axis. So if it's the x-intercept, it's where it crosses the x-axis. The y-intercept is where it crosses the y-axis, and you can also use this information to help you. On the x-axis, y is equal to 0, and on the y-axis, x is equal to 0. Okay, so that's your general overview. Now we're going to talk specifically about graphing linear functions. So we're going to go ahead and get a blank flashcard out, and this is going to be number 10. And this is called graphing linear functions. And I'm going to show you two ways to graph a linear function, and then you will be able to just do this whichever way you're more comfortable with. Switch back and forth if you need to. This is Unit 3, so this is the very first topic for Unit 3. Okay, so there's two ways, as I said, to graph a linear function. The first way to graph a linear function is by making a table. We actually have done this a little bit in Unit 1. We made tables to graph some functions, okay? So when you make this table, the first thing you're going to do is get y alone. You want your equation to resemble that f of x equals mx plus b or y equals mx plus b if there's a y in there, okay? And then you're going to use your calculator or substitution, if you don't have a graphing calculator, to make a table. Okay, and once you have that table, that gives you the points that need to be plotted. So you will plot your points and then finish up your graph by connecting them and putting arrows in a label. Okay, so that's just a quick little synopsis of how to make a table. I think you have done that in the past, so that should sound somewhat familiar to you. The second method is a little bit more efficient and does not require a calculator, and this method is using the slope-intercept form. Okay, so I'm going to spend more time talking about this because, like I said, this is a little bit more effective, less time consuming, and does not require a calculator to do this. So our steps here are going to be get y alone, and that's what we did on the previous one. So you're always going to have to get y alone first. So it always has to look like y equals mx plus b before you actually go ahead and graph. Next, you're going to plot the y-intercept, which is the b in the equation y equals mx plus b, on the y-axis. Okay, so you're going to plot a point right on the y-axis, okay, and that's going to be your first point. Then you're going to go ahead and use your slope. Slope is the m in the y equals mx plus b equation to plot more points. And how are we going to do that? We're going to use the concept of rise over run. Okay, so when you write your slope as a fraction, The top tells you how much to rise, and the bottom tells you how much to run, just like that formula I just showed you with the y's on top and the x's on bottom. And then you're going to draw the line, put arrows on it, and label it. Okay, so let me show you what that would look like. Let's say we have the equation, get a different color here, 2y plus 2x equals 6. Okay, we're going to go ahead and get y alone. We always add or subtract first. So here's the y, and being added to it is 2x. So we're going to subtract 2x because we have to use the opposite operation. So that gives us 2y equals, now we want this to look like mx plus b. So I'm going to say negative 2x plus 6. The 2 is negative and the 6 is positive, and I want that in that same order as the mx plus b. Now go back to the y. We have to get it alone by dividing by 2. Now you're going to divide everything by 2. This should be looking familiar because we did this in Unit 1. Negative 2 divided by 2 is negative 1, so you can say negative 1x or just negative x, plus 6 divided by 2 is 3. So this line, we're going to say m is equal to, well, it's the number in front of the x, so that's negative 1, but we need it to be a fraction, and since it's a whole number, we make it a fraction by putting it over 1. And the y-intercept, the b value here, is the 3, okay, the number by itself. All right, so if we want to go ahead and graph that, I'm going to make a little graph here. I'm just going to kind of sketch this because obviously I don't have actual graph paper right here, but I'm just going to make myself a little graph and put some marks on the axes so that I can follow along here. This is just a quick little example, and then we're going to do a couple of examples on that worksheet I gave you in class. Okay, so you're going to start with B. We always begin with B. Okay, once we have y alone. So we look at b, which is 3, and that goes on the y-axis. So from the origin, I'm going to go up 3 so that I have a point plotted on the y-axis at 3. The slope tells me the rise and the run. So I'm going to rise negative 1, run positive 1. To rise negative 1 means to go down. So I'm going to go down 1 and to the right 1. And then I'm going to do it again, down 1 and to the right 1. Okay, so I'm rising negative 1 and running positive 1. And you can do that a bunch of times here so that you get a really nice look at what that line should look like. If you have a ruler, you can go ahead and connect those points. Now, of course, mine is off a little bit because it wasn't a perfect graph to begin with. But when I have a nice perfect graph, these points should line up perfectly. Okay, so there's my line. I'm going to label it with my original equation, 2y plus 2x equals 6. And that's what it looks like when you graph with the slope and the intercept. So what I want you to do now is to grab that worksheet that I handed out to you in class, the white worksheet entitled Graphing Lines, and we're going to go ahead and do a couple. I'm going to show you how to graph by making a table, and then I'm going to show you how to graph using the slope and intercept one more time. Okay, so the first thing we need to do here, I'm going to transfer my equation down here, 2x plus y equals 5. We need to get y alone. We start by adding or subtracting. So this is the y right here, and I'm going to need to get rid of the 2x. The 2x is positive, so I'm going to subtract 2x on both sides of the equation. Okay, those are going to cancel, and it's going to give me y equals. Now, one of the most common mistakes I'm seeing here is that people are trying to subtract these values. These are not like terms. One of them has an x and one does not, so they cannot be combined together. So you want to make this look like y equals mx plus b. The number with the x is the negative 2, so I'm going to write the negative 2x first, then the number that's by itself, which is a 5, and since it's positive, I'm going to put plus 5. Okay, now I'm going to make a table for this. Okay, so I'm going to do x and I'm going to do y. If you are using substitution in the middle, you're going to need to fill in the equation that you're using. And you're going to just pick 3 numbers for x. It doesn't matter what you pick. I'm going to pick negative 2, 0, and 1. Okay, so it's good to have a negative, a 0, and a positive, but you can really pick any 3 numbers that you want. So if you're substituting, you're going to fill this in for x. This should be looking familiar from Unit 1. So I have negative 2 times negative 2 plus 5. and that negative 2 times negative 2 is 4, plus 5 gives me 9. On the next line, I'm going to have negative 2 times 0 plus 5. I'm substituting for the x right here, the number that I have over here. That would be 0 plus 5, which is 5. And finally, negative 2 times 1 plus 5. And that's negative 2 plus 5, which is 3. Okay, so these 3 points need to be plotted on this graph, okay? Now, negative 2, 9 is not actually going to fit on my graph because my graph only goes up to 6, okay? So I'm going to skip that one for now. I'm going to plot 0, 5, and I'm going to plot 1, 3, okay? Now, 2 points is not quite enough to get a line, so what I need to do now, since my negative 2 didn't fit, is I need to pick one more value. So let's go ahead and just pick 2. So now we're going to substitute in negative 2 times 2 plus 5. Negative 2 times 2 is negative 4 plus 5 is 1. So I have the point 2 comma 1, and that goes here. Once you have 3 points, you can go ahead and graph your line because 3 points constitute a nice line. Then we know that they all fit on the same line. We didn't make a mistake. Notice that I'm making my line as long as I can on this graph. It should go all the way to both ends of the grid. And I'm going to label it with the original equation. Again, some of these things should be sounding familiar from Unit 1. Okay, let's look at number 2. Now we have y equals 4. So we don't have to do any work to get y alone, it already is. You might notice that the x is missing from this equation. So that means that when we substitute, it's going to be a little bit of a weird situation because y is equal to 4. It has no, the x has no effect on the y. So I can pick whatever I want for x, negative 2, 0, and 1, pick the same numbers. But y is equal to 4 no matter what x is. So I'm always going to have a 4 for y. Okay, so let's plot these points. Negative 2, 4, it's going to come up here. 0, 4, and 1, 4. And hopefully you can see that we're forming a horizontal line. If the x is missing from the equation, then the slope is 0, which is that flat line that we talked about on that first flashcard. Okay, so there's your line. Label it y equals 4, and there you go. Okay, so if the x is missing, the slope is 0, and you have a horizontal line. Let's do one more example, and this time we'll go ahead and use the slope-intercept form to help us, okay? So we're going to start by getting y alone. Now I chose this one because it's got a little bit of a trick to it. The first thing we're going to do to get y alone, of course, is not look at the y, but look at what's over here and get this x to the other side. Since it's positive, I need to subtract it. Okay, this negative sign right here has nothing to do with the x, okay? It's a positive x, so I'm going to subtract it on both sides. Now this negative is attached to the y, so that comes down with the y. And again, make this look like mx plus b, so negative x plus 3. Now, y is not alone. There's actually a number in front of the y, even though it kind of looks invisible. There is technically a negative 1 there. I have to get rid of that before I can graph this. So I'm going to divide every part by negative 1. Notice I'm doing that 3 different times. And y is going to equal, well, this is like a negative 1. Negative 1 divided by 1 is 1. So that's just x, or 1x. And 3 divided by negative 1 is negative 3. So what is the slope of this line? The slope is the number in front of the x. And in this case, the number in front of the x, which we can't see, is 1. If I want to make that a fraction, I'm going to put it over 1. So I have a slope of 1 over 1. What is the y-intercept of this line? That's the number that's by itself. Very careful here because it is a minus 3, which makes the y-intercept negative 3. Okay, so as we talked about a few minutes ago, we're going to begin with b. So b gets plotted on the y-axis. Okay, so I'm going to come over to the y-axis and find negative 3. Y-axis is up and down. It's labeled if you're not sure. Sometimes it's not labeled though, so you do need to know that. And I'm going to plot negative 3 on that axis. Okay, now my 1 over 1 here gives me rise over run. So I'm going to rise 1 and run 1. They're both positive, so I'm going to move in the positive direction. So rise 1 means up 1, run 1 means to the right 1. Rise 1 means up 1, run 1 means to the right 1. And you can keep going with this pattern all the way to the end of the graph, and you can even reverse it. So if I went up and to the right, now I can reverse it and go down and to the left. You have to reverse both directions, and that makes a nice straight line for us to graph. Go ahead and connect the points, arrows on the ends, and don't forget to label with the original equation. Okay, I hope this video helped you understand how to graph lines 2 different ways by making a table, and you can use your calculator to make that table. I'll show you how to do that in class, or by actually using the slope and the y-intercept to help you graph that line. I hope this was helpful, and I will see you in class.